Alice. So say that, why don't you try to settle this transaction through them, so that now we are going to create an IOU link which goes from Carol to Alice for $10. The link between Alice and Bob changed from 100 to 110 for the same IOUs because of settlement. And similarly, we had a link that went from Bob and Dave for $10. And the hope is that because Bob and Dave know each other, they will settle it in the future, and so is Allison. So in general, if you look at credit network, it can be looked at that we are performing settlements. However, we are not transferring money in principle. We are transferring money in the form of, from one party to another form of IOUs, or maybe we can also use another term called promise for payment in the future. And if you look at our credit network in general, you can just look at such a network. I'll not say word gigantic, but whatever, it could be huge networks of such IOUs, which is between all these different participants. And whenever there is a settlement that has to happen, let's say here, our friend Carol needs to pay Bob $15. What they should do is that in such a network, they should find a path or a set of paths which goes from Carol to Bob and try to settle this particular transaction in such a setting. So here, that is very similar to what is known as max flow computation problem in general. And what happens is that these are the two paths which are employed, and appropriately we can see that those paths will be changed from, that link between Bob to Carol changed from 5 to 0, and other 10 are drawn from the other credit link. So that's a core concept, and if we do not have a relationship available between two participants, or neither the path, then we have to create the links if they want to perform transaction into such a system. And that's how the system makes progress, add new links, reduces links, and so on. In general, so if that's how typical credit networks looks like, and now the question that we should ask is that, okay, interesting, but why should we use this, and why not rely on, I'm going to step into the blockchain crowd, so why can't we just use cryptocurrencies to perform this transaction? So what unique benefit this credit network brings? So one of the first thing is cross-currency transfers, so that now these links could be of different currencies, and we can allow exchanges between different currencies and perform currency transaction which goes across fiat currencies, cryptocurrencies, as well as user-defined currencies. And because of adding user-defined currencies, we can indeed build what we can call as a bartering dream, where we can define different currencies and allow exchanges in those and perform different transactions. It can also provide improved and ideal situation, potentially unlimited liquidity, because such IOU links are inherently trust links, and then we are no longer restricted by the supply of any currency that is available to us. Our industry is made from the loans, and loans are significantly more than the liquid currency that we have in the system. And these credit networks allow us to model this environment, such a system, and that's the reason we could have significantly more liquidity through such systems in general, but still bounded by the paths that are available there. And we can, because here when nodes are getting added, we can inherently associate them with the regulation, with the geography. So these systems have found to be much better in terms of compatibility with the regulation which are associated with geography or geopolitical situations. We are going to very soon see that they can be also really good at tolerating Sybil attacks. And in fact, at the end of my talk, I also wanted to really demonstrate to you that we can go beyond and possibly use such systems to even avoid requirement of global consensus itself, which has been one of the key challenge in terms of the scalability of the blockchain in general. So let's take one step at a time. And indeed, there are already examples of this credit network. So this concept is the core regarding Ripple and Stellar design. For example, here the nodes create links with different banks, as well as in different currencies, as well as cryptocurrencies, and so on. And the aim is one can create such a complete network of different cryptocurrencies as well as fiat currencies and allow transaction across them, which is the feature that provides. And so in this manner, credit networks, or at least the example here, Ripple and Stellar, can provide really significant improvement towards the remittance and the cross-currency transaction in general. And indeed, that we have seen, this is some recent work that we look into understanding how the credit networks are building up, and this is the rate of a Ripple. And there's a significant communities that are getting developed all throughout the world. And same is the case to a lesser extent with the Stellar, where they're focusing mostly into the developing world and trying to provide efficient solutions in that space. So not only that, I already mentioned that they are good in terms of the Sybil tolerance. And what I mean by that here is that look at this example that I'm showing there, and this Eve is our malicious participant. And she has been provided these IOU things from Bob and Alice, and the only thing that she can do is to default them and not pay them back. So indeed, in credit networks, the amount of badness that can be done is limited and bounded by those local links. So it's bounded and localized. And that has a huge interesting applications, not only also to the payment world, but in general the trust network itself. And we generally going to consider the credit networks into the settings regarding payments, but their applications have been found beyond in general. And in general, there is a whole area called Sybil tolerant applications, where if we assume that there are adversary can create any number of Sybil nodes and try to assign create any kind of structure in this environment, their capabilities in terms of creating harm to the good part of the network is limited by the amount of IOU that they can gain from the good part. And let's say here they are basically forming such a edge cut which goes from the good part to bad part. Important thing to look at the direction of the links over there, which should be going from the Sybil nodes to the well-defined nodes. And the key point there is that introducing nodes does not help adversary. All that matters is the amount of IOU trust or amount of IOU links that they can create, which goes from those Sybil nodes to the well-behaved nodes, and only they are the matter. Well-behaved nodes, if they do not allow such creation of the links, then certainly they cannot affect that much to the overall capacity as well as the functionality of the network. And this has been employed into all different scenarios. There are the academic works to preventing email spam, to strengthening the marker space, or to provide Sybil resident voting, where all these credit network concept has been realized. And as we know, as we already talked about, Ripple and Stellar are also payment network systems which are in place. So seems good. Like, I mean, seems like we have nice solutions. Where is the issue, or what's the issue over here? So the issue, or the question is, where are the problems exactly are? So the first thing that we want to ask is that if you take the examples such as the Ripple and Stellar as the two examples that I'm start with, they introduce native currencies, and they say the purpose for that is that to perform transaction, you should pay fees in these particular native currencies, and that's the reason if you want to basically use such a system, you have to buy native currency from us and use that. And the reason they gave is the spamming protection. But isn't it the situation that the credit network themselves has very interesting features towards stopping the spam just in the IOU network itself, as we saw with this Ostra example just on the previous slide. So indeed, it's certainly not necessary. On top of that, there are issues in terms of the way the governance is happening in such system, and there are questions which are asked, are they truly distributed systems or not? I mean, why we require a centralized control over the native currencies, the amount of native currencies employed or required for the transaction, as well as why there has to be a permission network to manage such systems. There are all sorts of questions regarding the centralized government that comes in picture. On top of that, privacy is a huge issue, even bigger issue here as compared to Bitcoin and such currencies, because inherently when you create a node and you garner IOU from there, you better use that. And to use that, you have to continue the same node again and again. So inherently, privacy becomes a significantly bigger challenge over here to deal with. So what we try to do in this particular phase, the first step that we took in this particular step is to decide, can we build this complete credit network setting just by itself as a contract on Ethereum. The hope is there that at least now we will not have a centralized control. We will not require any cryptocurrency, so it's completely tokenless. The only limitation that we'll have is that to perform a transaction, it will be transaction on Ethereum, so you have to pay for this particular transaction in terms of the gas that is required to perform the transactions. And then what we did is that we wrote the complete contract for a credit network for creating the links, performing transactions, and trying to compare those costs as compared to the cost that we will incur as compared to the price that are put forward by Ripple system in terms of XRPs, as well as when we compute the gas that is required for this process, and then appropriately convert that to the cost for the USD. and then we compare the costs, and certainly some of the things are inflated if you look into the Ripple networks, and the entry barriers are unnecessarily created higher while the transactions are unnecessarily created lower. So we look at what we did as a study to understand that, let's say if we wanted to build such a system on Ethereum, how will it look like, and what kind of cost that can come in picture. And we observed that there is an interesting trade-off, and if we let this system work as a market-driven and not driven by the whim of a particular environment, indeed there are different kind of things that we can observe in that particular space. But while in the beginning, or maybe somewhere in the between, I mentioned that we do not require a global consensus for such a process, right? But we are still using the consensus to perform this transaction we write as a smart contract. So it's necessary question to ask that, is it really that the consensus is necessary for that purpose or not? And that's where we want to talk about an observation in this particular case. And that observation is that if you are a credit network node, only thing that you need to know is your local knowledge, your links to your friends or your neighbors, okay? Things that happen beyond that probably are not so much necessary for you to know, because all your transactions necessarily comes to you and goes through you, comes from your some of your neighbor and go to somewhere else. So as long as you keep that local information for your neighborhood, that is sufficient for this purpose. Let me take an example. Let's take this very simple example over here, and our person under consideration, Bob. So Bob sees that there's an inflow of 250 from IOU from the CBW bank, and then there are two links that are going from Bob to two different participants for 15 and 25. So for they say that my inflow is this much, my outflow is this much, and my net flow is approximately 410. And let's say a transaction that is getting executed somewhere in the network which does not involve this participant that we show on the graph. Then Bob here has nothing to do with this transaction because it does not change anything associated with Bob. Any transaction that has to happen through Bob should go from these nodes which are connected to it. So let's say, in principle, let's say a transaction happening where we are looking at a transaction which starts from this node on the top, let's say Charlie over here, and goes to the bank, and the transaction value is it's in particular $5 here. Now, what's going to happen here is that the links appropriately between Charlie and Bob will reduce from 15 to 10, and the link from Bob to the bank will reduce by again 5 to 545. So in principle, the inflow and outflow change, but then net flow remain the same. Okay? So even for the transactions where Alice is involved, their net flow have not changed as long as they are either the sender or the receiver of the transaction. And for all other transactions, they don't care. So what it talks about in general, such system for credit networks in general, is that we do not really worry about what's happening in the rest of the network. I'll just translate that thought into other things. We do not require a global consensus for the sanity or the correctness of the system. What we care about is our links to our friends or our neighbors. We don't, as I already mentioned, we don't care about links between friends and friends of friends. Okay? As long as we have kept our links to the counterparties that we are willing to assign to our neighbors, the complete network can be built just as a distributed system without requiring a global consensus. Okay, so that's a message I want you to take and from this particular talk for sure. So moving on, what we did is that we indeed have been, based on this concept, have been developing the concept of decentralized credit network in the part of few academic papers, but also the implementations, and indeed looking forward to building system on top of that, where we define in such setting what kind of privacy problem that privacy we expect, and then develop solutions based on that. One more advantage that decentralized design will have, that because there is no blockchain, that means there is no centralized ledger, so there is nothing easy that is available to analyze and break the privacy for the whole environment, which is a huge problem in all systems, including Ripple and Stellar, where all the ledgers are available in public. So how a distributed ledger credit network looks like, so let's say this simple subgraph we take. Here, if you can see, if you take Carol as our user, she only could need to remember one link, that is from her to Bob. And Bob is also again going to link only the part of the network that is relevant to it. Okay, and the aim is to now perform transaction in this case. The first question to ask, what kind of problems that we have to deal with in such a setting, okay? So although we are removing blockchain, but we are still essentially interesting atomicity problem that we have to solve. We want to make sure that if you're performing a transaction that goes from Alice to Bob through few intermediaries, or that transaction happen in atomic manner so that all links are changed or no link is changed. Okay, so that we require. We want to also make sure that the participants that are performing transactions, no outsiders have no clue what is the value of the transactions, okay, or who is transacting with whom. And but even beyond on top of that, the key question, if we assume that we do not know the network beyond our neighbors, the challenge is to find out the paths in such a network. And also not only find out the path which has enough values to perform this transaction. Okay, so the question is how we perform. How can we can call this problem as solving the problem of distributed routing in general. And I'm going to start with that problem. Okay, so obviously you can think of a distributed version of MaxFlow where you start from a node and run a completely distributed algorithm, go through several nodes and try to find out path which goes from the source to the sink. But certainly it has been known that these distributed MaxFlow problems are inherently difficult. I mean, they could be quadratic or even quadric in terms of the complexity. So they are certainly not going to scale really well in general. What we found to be efficient enough in most scenarios, because the way credit networks are made up, is to use some simplification which may lose some paths but still provide enough liquidity to perform the transaction. The prominent example that we picked from the way internet also built is landmark routing, where we'll assume that there are some bunch of nodes which are high connectivity in the system. And what we are going to do basically is to create some kind of a spanning tree, BFS, DFS, mostly BFS spanning tree from these nodes, such that every individual node we know that these are my neighbors, and if I want to reach this particular landmark, which is well-defined, well-known node, here is the next guy that I should go to. So very similar to the internet. If I want to connect somebody on the internet, I better know my router, and that router will take care of that. So here also I'll inherently assume that this is the router I should pick to go there. Okay, and what we'll try to do in such environment is we'll just create such spamming trees for nodes, and now basically create some landmark universe in a distributed fashion where node only knows how to reach a landmark node, which of my neighbor I should pick to go to that landmark node. And now whenever we want to perform transaction between two nodes, we are just going to pick, find where they are, and they'll basically try to find out, hey, can I reach this other guy through my landmark universe? And when they find such paths between those guys, now they have to basically stitch those paths through the landmark universe. Okay, and now try to perform. So that's how we look at landmark routing. We also have built some other interesting solutions which build on top of that and provide efficient routing here. But then not only our problem stops there. The next thing we want to make sure that as atomicity, that when transaction goes from Alice to Bob, that it is completes in atomic fashion. And there the ideas that we use are basically just using a two-phase commit, or I'll use a not so technical but still relevant word, they are local consensus, where we want to make sure that we perform this transaction in terms of this first hold the transaction account. Basically, let's say we want to perform again transaction for $5. What will happen here is that basically from Alice here to the next node, we'll hold $5, and that there is incentive because the phi IO is reduced from the perspective that's first neighbor. He will also incentivize to now create a next lock, which again for the same account, and so on. We continue until we reach the final node. And once the receiver sees that, yeah, there is already $5 which are locked in this such a mechanism, now they'll say that, yeah, let's open these locks. So they will open those locks that, okay, I received it, and they will open these locks in particular fashion so that the transaction will perform in atomic session. Okay. So those of you already know Lightning Network or payment channel network. Indeed, this mechanism for performing these transactions is very similar to what you have what we do with the hash term-like contract. But here, because we don't have any restriction, that we'll probably try to use signatures rather than hash lock time contract. But indeed, this is basically two-phase commit or the local consensus that one can employ to perform this transaction. Okay, so now coming to the end, when I see here what kind of solution that we have seen today, okay? So starting from cryptocurrencies, indeed, in cryptocurrencies we are allowed to perform transactions between any two wallets which accept these currencies, and that's the reason we required a global consensus. But if you look at Lightning networks or Ripple, transitory network, Silent Whisper, basically Lightning network is a payment channel network on Ripple, on Bitcoin, and then Ripple, Transitive Network, and Silent Whisper. All these, they perform transactions via path for the credit, for the credit networks, and via currency path for the Lightning Network. In that that's the way that money is transferred. In terms of the transaction flexibility, obviously there is a fixed currency for the cryptocurrencies and the Lightning Network, but we can allow cross currencies when we in the credit network settings. When we come to the indeed transaction confirmation, that's where the interesting things happen. Obviously, for cryptocurrencies, we may have permission ledger or whatever. For Lightning Network, it will be two-phase commit by the users on the path. For Ripple, it's a federated consensus, whatever that federation is. For Transitive Network, again, it could be, as we looked into, it is a permission Ethereum system where we rely on. And for Silent Whisper, which was the distributed solution that we looked into, it will be again two-phase commit that we perform with the local transactions. In terms of privacy, indeed, now the final things are there are consensus privacy-preserving extensions that are available in this space. In Ripple, we build solutions for them, but they are not interested in the privacy in general. For Transitive Network, again, there could be solutions in Ethereum space which could be employed in that case. While certainly we can achieve really strong privacy property, which I could not go into the detail over here, but it's available through our work that we can achieve, and certainly have the best possibility to achieve those properties here. And with that, I'm coming to the end of my talk. So what we saw today, the first thing was that credit network have interesting properties, and indeed they could be considered beyond just cryptocurrencies. And the growth of Ripple and Stellar indeed show that that has a value out there. Then we also, and especially in the remittance business, there is a significant value for such things. Then we looked into concept that how can we build such system in a more permissionless setting, and the example that we put was building a credit network system onto Ethereum. That's a transitive network, and you can find out all our work from transitive.network.com. And finally, we looked into different landscape that one can see in this case, where our focus was all these different either payment channel networks and the credit network, and we observed that they provide different guarantees in terms of the security and privacy, as well as consensus, and can provide us an interesting way to go forward. Finally, yeah, thanks a lot for attending audience. If you want to know more about what we do or these things, feel free to contact me via Twitter, or if you can find information regarding me from our webpage. Thanks a lot.